Hi, in this video we're going to be talking about compositions of functions, which is where we put functions inside of each other, similar to a turducken, a turkey and a duck and a chicken. So here I've got my two functions, f of x and g of x. This is our notation to say that, hey, we want to do a composition of these two functions. So this fog means f of g of x. So into f, we want to put g of x, which is 2 minus x. So we want to take this 2 minus x and put it where the x is in the f of x. Once we do that, it turns into this. We've got our 2 minus x getting squared because that's what f does, and then we want to subtract 1. We can then simplify this down because that's a two-term things needing to be squared, a binomial. We would have to FOIL that. So 2 minus x times 2 minus x. When you multiply those together, you'd have to do a FOIL. So that is going to be 4 minus 4x from minus 2x in the middle and a minus 2x on the outside. And negative x times negative x will be x squared. And then we still have the minus 1 that's on the end, but we can put those together in order to make 3. And I'm just going to put the x squared and the minus 4 first, just to kind of like clean up the problem. And that's f of g of x, or fog. If we want to do goff, or g of f of x, that is the reverse. So we want to put f of x, this x squared minus 1, where the x is in g of x. We're placing the x in g of x with f of x. And so we want to find g of x squared minus 1. So where that x is, we're going to put an x squared minus 1. And then we've got a negative in front of there. We want to subtract all of whatever f of x is, replacing that x with parentheses around the x squared minus 1. And then we can distribute that negative into there. So we get 2 minus x squared now plus 1. And then it's just a matter of putting that 2 and that 1 together. So we get 1 minus x squared. Now, something to be careful about not confusing this operation, this composition with, is multiplication. If we were to multiply f times g or g times f, either one, you can see that in both of those cases, this multiplication is producing something very different from this composition. We don't want to multiply when we see this open circle. What we want to do is put one function into the other function. In this example, I've got a rational function and a quadratic, and I want to figure out what fog is. So in the x of f of x, I want to put a g of x. That is what fog is representing. Okay, so right where that x is, we're going to replace that with a 3x squared. I like to always put parentheses there, just when I'm doing that substitution, just to make sure that if it does matter, it's there. But in this case, where it doesn't matter, oh well, I have that parentheses that doesn't really do anything. So that's about it in terms of simplifying that composition. Over here in Goff, when we do g of f of x, I want to replace the x in g of x with an f of x. So that is going to be g of 1 over x minus 1. And so where that x is, I want to put a 1 over x minus 1. And here that parentheses is really important because we want to multiply all of that 1 over x minus 1 by itself. So multiplying that with itself, I'm also going to make that 3 a 3 over 1, because then I've just got this big fraction. That top becomes 3 times 1, which is 3. In the denominator, that 1 doesn't really do anything, but I do need to FOIL that x minus 1 and the other x minus 1 in the denominator. That x times x is going to be x squared. We get a negative x and a negative x, so that'll be negative 2x, and a negative 1 times a negative 1 is a positive 1. So we get this for our Goff. Now keep in mind, this composition is different than multiplication. If we were to multiply f times g or g times f, either way, you can see in green down there that 3x squared over 1 minus x is very different from this composition that we have done. So if you see that open circle, that does not mean a multiply. It's the dot that means a multiply. This is composing, where we take one function and we put it into the other one. Right, Mel? In this example, I've got two rational functions this time. I kept f of x the same, but the process is also going to be the same, where in that x, we want to put g of x in order to do fog, f of g of x. So 1 over x is going to go right here. I'm going to put parentheses around it. Oh, well, actually, I guess not this time, maybe because it's too much stuff. But you could put parentheses around that thing. Then I want to simplify this down a little bit. In order to simplify that, I want to multiply the top and the bottom of this major fraction with an x. So that's really multiplying each term with an x. So 1 times x is x, 1 times x is x, and 1 over x times x will just be a 1. I've got an x over an x, that's just a 1. That's so I can get rid of the fraction that's inside of our fraction. If we want to do g of f of x, that's going to be gaf. So that's saying, okay, we'll take this 1 over x and put it where this x is in f of x. So replace the x with a 1 over x minus 1. Ooh. So that's going to look like this. I've got a 1 over all of that stuff. In order to simplify this down, it might be easier to think about it and saying, hey, that is just, that fraction means divide. So this is really 1 over 1 divided by the denominator, 1 over x minus 1. So then in order to finish simplifying this, I can just use keep, flip, change, flipping this over and changing to multiplication. Then my simplification is easy. 1 times x minus 1, that is just x minus 1. And in the denominator, we have a 1 times a 1, so that's just a 1. Keep in mind, this composition is different than a multiplication. If we were to multiply these two fractions together, whether it's f times g or g times f, wouldn't matter. We get this very different answer than what we would get when we compose the two functions. So this O is a composition. Put one function into the other one, not a multiplication. That is just the filled in dot. A type of result that we really get excited about when we're composing functions as mathematicians is just getting an x back out. So we're going to show that these two functions, when we compose them with each other, we get just an x. So I want to figure out what f of g of x is. So remember, this is the same as fog. Replacing that x with a x minus 4 over 3. So I want to find f of x minus 4 over 3, which is 3 times x minus 4 plus 4. Notice that I've got that parentheses around that x minus 4 in order to make sure that I multiply this correctly. If I'm multiplying and dividing by 3, those two operations undo each other, and we're left with just an x minus 4 plus 4. The minus 4 and the plus 4, those also undo each other, and we get just 0, so we just get x plus 0, x. If we do it in the opposite direction, g of f of x, I want to put a 3x plus 4 in the numerator of this fraction where that x is. So that's going to be 3x plus 4 minus 4 divided by 3. And I put the parentheses there just in case, but they don't really do anything. So then I simplify by saying, okay, well, plus 4 minus 4, that is 0. So those are gone, and we have a 3x over 3. 3 divided by 3 is going to be 1. So it's just a 1x, which is the same as x. So we've just shown that f of g of x and g of f of x both equal x in that composition. In this example, I've got a square root and a quadratic. I want to compose these two functions and show that they're both going to produce just a regular x. So f of g of x, I want to replace that g of x with the x squared minus 4. So now I want to put the x squared minus 4 into f of x. So right where that x is, I'm going to put the x squared minus 4. I put it in parentheses just in case it matters, because it's better to have it and not need it than need it and not have it. Because it doesn't really do anything. It just kind of goes away, that adding 4 on the outside doesn't change what's on the inside. Negative 4 plus 4, that is just going to be 0. So inside we just have an x squared. The square root of x squared is just going to be x. I don't get a plus or minus there because everything you're seeing me do here is a simplification, and we only get that plus or minus if we do square root as a solving step. Over here, I've got g of f of x. F of x is the square root of x plus 4. So I'm going to replace that here, and that's telling me, hey, take the square root of x plus 4 and put it where x is in g, okay? So I put parentheses around it and I square. It does matter this time because I want to square all of that square root. If we square a square root, that operation undoes each other. So we're left with just the x plus 4. And then we do our plus 4 minus 4. That's just going to be 0. So we get just x. So we have just shown that f of g of x equals x, and g of f of x also equals x. In this example, we again want to show that these two, when composed, both equal x. So we want to take for f of g of x, which is all of that mess, it's a big rational. We want to plug that into f of x. But notice that there are two places inside of that rational where all of this mess needs to go. Ooh. So, well, here we go. There it is. So I've got that 7x plus 2 over x minus 1 showing up in this top part, and it needs to show up in the part on the bottom. So really, I'm just kind of writing it twice, one with a plus 2, one with a minus 7, and then it's all separated with a division. In order to simplify this down, I want to multiply the top and the bottom by the least common denominator. Fortunately, that least common denominator is the same thing on the top and the bottom of that x minus 1. So I'm going to multiply the top by x minus 1 and the bottom by x minus 1 in order to simplify this fraction down. This 7x plus 2 multiplied by x minus 1, that's just going to be 7x plus 2. And just to keep things simple, I'm not going to multiply out the 2 times the x minus 1 right now. All this did was got rid of the x minus 1 that was under the 7x plus 2. The same thing's going to happen in the denominator. This x minus 1 and that x minus 1 are going to cancel. So I still have that 7x plus 2. And I'm not going to multiply the 7 and the x minus 1 yet because I want to try to simplify what I'm doing in this step. Otherwise, that's just doing too much all at once, and it leads to more mistakes. Now I want to distribute. Now I want to distribute that 2 in there, distribute that 7 in there. So I get 2x, and 2 times negative 1, that's 2. And then negative 7 times x, that's negative 7x. And negative 7 times negative 1, that's 7. Now I can simplify this stuff. I can combine like terms. 7 and 2 make 9. 2 minus 2, that's 0. 7x minus 7x is going to be 0, and then we got that 2 plus 7, that gets us 9. And we're really excited about that because 9 divided by 9 is x. Fortunately, they told us what the answer we should have gotten at the beginning. Let's do that one more time, but we're going to do it the other direction. We're going to take f of x, this fraction, and put it in the two places in g of x, in the x on the top and the x on the bottom. So on the top, we've got 7 times that whole fraction. I put it in parentheses because it does matter that we have that parentheses there. Plus 2, and then x minus 1. So x is all of that stuff now because we've got all of that stuff minus the 1. Just like we did over on this problem, we want to multiply the top and the bottom by x minus 7 in order to try to simplify down what's going on in that numerator. So I'm going to multiply everything on the top by an x minus 7, and we're going to multiply everything on the bottom by an x minus 7. So simplifying this numerator, again, what happened over here is that x minus 1 just went away. So the x minus 7 will go away here. We'll still have the 7 times x plus 2, and then that 2 gets multiplied by the x minus 7. This x minus 7 and that x minus 7 cancel, but here with the 2, it still has that x minus 7. Remember, this is distributed into there. If we check down here, this x minus 7 times this x minus 7 will cancel out. So we're just left with the x plus 2, but we still need to distribute the x minus 7 into this negative 1. So we get negative 1 x minus 7. Now I'm actually going to multiply all that stuff together. 7 times x, that's 7x. And 7 times 2, that's 14. 2 times x, that's 2x. And 2 times negative 7, that's negative 14. On the bottom, we got to distribute this negative 1. So negative 1 times x, that's negative x. And negative 1 times negative 7 is 7. Now it's a matter of combining like terms. In the top, we got 7 plus 2, that's 9. The 14 minus 14, that's 0, so that's gone. X minus x, that's 0. And 2 plus 7 is 9. And 9 divided by 9 is 1. So we got just the regular x that they told us back in the beginning that we should get. That is it for our video on compositions of functions. Remember that this composition is not a multiplication. This fog means putting one thing into another. What happens when we put a chicken and a duck and a turkey? Putting those functions into each other, not a multiplication. Multiplication is just that plain dot. Thank you so much for watching. Bye-bye.